Buenos dias or buenos noches. I don't know. Maybe you're a night owl and you're doing your notes at night. I don't know. Just grateful you're doing your notes at all. That's all. So, notes, Math 7, 8-2 today, focusing on measures of variation. The last lesson focused on measures of central tendency. This one focusing on variation. When analyzing data, one of the main things we look at is variation. The other main thing we look at was center, which is what we focused on yesterday. So variation, remembering that variation means how it changes, how it differs, how it varies, how consistent that data is, how it varies. So there are measures of variation, just like there are measures of central tendency. And believe it or not, there are 3 measures of variation, just like there were 3 measures of central tendency. And these measures of variation, they actually measure how spread out the data is. How spread out the data is. We're stuck. There we go. Some other keywords you saw in practice problems for last night was asking you about which class had the most consistent test scores. That's another name, consistent. If there's a lot of consistency, that means there's not much variation. Consistent coming from constant, it being the same. So again, how consistent it is, how much it differs, things like that. And the 3 measures of variation that we're going to look at below are first, range, second are quartiles, and then 3 is the interquartile range. First up for range is pretty chill. Range, to find the range, you take the maximum number and you subtract it from the minimum number. So, in layman's terms, that is the highest number minus your lowest number. And just in case, for our humans that don't have the best handwriting out there, we're going to actually write that word subtract so you know that that's what's going on there. So that's how you find range. The highest number minus the lowest number. Up next, we have quartiles. And quartiles are the 3 values that split the data into 4 equal parts. Now, that might sound a little sketchy because you're like, if you're splitting it into 4 equal parts, shouldn't you need 3 things? But we're going to sidebar real quick. You don't have to do this. But if I'm trying to take this rectangle and I'm trying to split it into 4 equal parts, that requires only 3 lines. One line would give me 2 parts. A second line gives me 1, 2, 3 parts. The third line gives me my 4 equal parts. If I had put an additional line in there, that would give me 5, and that's not what I want. So that's why we're using 3 values, and those 3 values split the data up into 4 equal parts. So up first, we have what is called quartile number 1, or Q1. And Q1 is actually just the median of the lower half of the data. And we'll talk more about that in our example. Q2 is your known and loved median back from 8-1, that middle number, kind of going through, putting it in order and finding out which one is in the middle. And Q3, if you've guessed it, Q3 is the median of the upper half of your data. And those 3 numbers are your quartiles. The third measure of variation is the interquartile range. The word range meaning or giving you a clue that you're going to need to be doing some subtraction, just like we did in the range up there in pink. And what the interquartile range has you subtracting is actually Q3 minus Q1. So basically, quartile 3 minus quartile 1. And the interquartile range is abbreviated with IQR. The I going along with the inter, Q for quartile, and R for range. So those are the three measures of variation that measure how consistent or how spread out your data is.